I have a second channel, Cube Comp MTDX. Hey everybody, here we're looking at the laptop battery for my HP Pavilion Sleepbook 15. This is a replacement battery pack that I bought for this machine a little over a year ago. The reason why it's out of the machine is because it's not working very well. So I spent about, I want to say around $20 on this thing about a year ago. It's an 8-cell extended capacity pack. It claims to be 5,200 milliamp hours. So yeah, I don't know about that, but about as generic as they can get. That's how a lot of these things are. Usually I don't have too many problems with these generic replacements. However, I have seen on a couple of occasions where they were not constructed very well. Remember the, for those who've been watching my videos, you might remember the 9-cell pack. It was a replacement for a Toshiba laptop. It had the purple cells in it, and the thing was just put together really horribly. Get this, look at this. You know how HP and Compaq products, a lot of their components will have little stickers on it that say replace with HP spare, and it have like a spares number on them. Well, this says replace with HC spare. HC spare. But yeah, it has a date of, looks to be 8/8/2016. So this thing apparently sat in a warehouse for about 2 years before it actually was sold to me. So what's going on with this thing is it charges up and it holds a charge, but it never has seemed to be quite accurate with its fuel gauge. The thing that tells you the percentage of battery life remaining, and it never seems to have been able to estimate a time. Like when you hover over the battery symbol in Windows, you'll typically see the percentage remaining and an estimated time remaining. Well, this one has always shown percentage remaining. And to put the icing on the cake, what it's been doing lately is when you get it down to about 15% or so, laptop just shuts off and won't power back up. Makes me wonder if the cells in this pack are not balanced properly, or if we have some cells that are going bad. So we're going to actually crack this thing open and see what I can find. Chances are likely that I'll be scrapping this thing of its cells, good cells. But I'm curious to see what's going on here. I tell you, this little sticker is hilarious. It's been a little bit since I've actually cracked open a laptop battery. Of course, you may obviously know that I do it. I mean, my cameras are all 18650 modded. You gotta get those cells from somewhere. So before I actually crack that thing open, let me grab the laptop. I'm pretty sure it's not going to bother to start. So I don't even have I only have a battery in this thing right now. Need to order one. And I must say, this is kind of disappointing. You know, order this pack and not even a year later, it's unreliable. You know, you can't have a battery that shuts off on you with no warning. As mentioned, the thing should drain down to extremely. Normally, Windows will shut the machine off at like 6% or 8%. But this thing, it gets down to like 3% and it just absolutely refuses to start. And you see it's not even powering up now. The battery has set for a while, so maybe it's not holding a charge. Maybe there's something going on inside of the pack. Maybe we have some cells that are bad. So what I want to see is if there's some cells that are holding decent voltage, and that there's a set of cells in this thing that are not holding a decent voltage. That's a lot of ways. That's how laptop batteries fail. And you'll have a group of cells. This is a 4S2P battery, meaning you have 4 batteries. You have 4 groups of 2 in series. And of course, the 4 groups are parallel with each other. It's kind of like my 18650 model, my cameras. The 2 batteries are running alongside each other. The 2 cells are running alongside each other in parallel. So I'm wondering how difficult it's going to be to get into this thing. Yeah, the biggest thing I worry about when I'm cracking these things open is shorting something out. But I am curious to see what kind of quality batteries we have in here. Usually with these replacement laptop battery packs, the cells themselves are generally okay. Matter of fact, the cells that I run my Red Sanyo camera, like what I'm shooting with right now, I actually run it off of generic cells out of a pack like this. I have 6 of them, so I have 3 sets. So typically with these, oh look at this. This thing might be pretty easy to get into. But typically with those, with the replacement battery packs, the generic replacements, the cells are, they work, but a lot of times the manufacturer of the pack likes to tell a fib about how much the cells hold. You know, they say that the battery pack is 5200 milliamp hours. Well, you'd have to have 2600 milliamp hour cells in this to actually achieve that. But a lot of times they'll pack in like 2000 milliamp hour cells to give you a total of 4000 milliamp hours. So quite a bit less than the advertised 5200 in that example. So I'm trying to find a good flat screwdriver. Sometimes I may have to use like an X-Acto knife or something. The thing is, when you're jabbing into these things, you gotta be really careful that you're not jabbing into, let's say, a jacket of a cell, or that you're jabbing into a contact. You know, I apologize ahead of time, but yeah, some of this is going to be done off camera, because I need to see what the heck I'm doing. Another thing I have to mention is in this pack, the circuit board is rather freaking close to the actual cells. The thing is, you don't want to damage you try to avoid damaging the cell wrappers, because they act as insulators. So I want to mention spots you want to be most careful on are these junctions right here. It's we have a positive of 2 cells meeting up with a negative of 2 more cells. You want to avoid getting metal parts inside here. And it looks like they have these wrapped in tape in these spots, which is a good sign. We'll know this thing a bit better once we can get inside and have a better look at it. So another thing I want to mention is I can tell already that our cells are, the positive is facing toward this direction. So negative is over here. So we have 4 cells. Negative, positive, negative, positive, negative, positive, negative, positive. So the spot you really want to use caution with when you're prying these things apart is anywhere, as mentioned, near the junctions, and it's anywhere near where the positives of any cells are. Because really the whole entire cylinder of the cell and the back of it is negative, but that one spot on the top is positive. And there's not much separating between negative and positive, so you have to be careful. The reason why I'm doing this is to go ahead and start isolating parts of the battery from the circuit board. Because once you get power isolated from the board, you can, it's a little safer to rough handle the board. So I gotta leave it like that for now because it's taped under here. What they did is they put a second layer of tape. They put one layer of tape around the cells and ran the wire through and put another layer of tape in. So yeah. Tell you guys, circuit board is like almost right up against the cells in this thing. It was like that in the factory HP pack too. So really, the generic company is just following HP's design. Now I don't know if HP ever did make a extended capacity style battery like this, but I say for the most part they're following HP's design. That's how the innards and stuff are put together. So the things I'm trying to be careful not to gouge up the wrappers on these cells. Because again, if I didn't mention already, which speaking of, I should be using these more. These can cut better. Yeah, I could have been a little bit further ahead had I pulled those out earlier and used them. One thing you want to keep an eye on occasionally is feel around the pack and make sure none of the cells are getting hot. Because if anything gets hot, you know you've shorted something, and it's probably at that point you better run for it. you better take this and run out the door with it and chunk it outside for it. You know. Let's hope something like that doesn't happen. That's why you gotta be careful with these. I think here pretty soon I'm going to do a video on lithium-ion cell safety. Okay, so now we can see how much of a gap we have inside here. Yeah, I tell you guys, I know I'm a bit slower at it, but I take my time and try to do it safely. You know, when I tear these things apart. Now I should mention this again. This is negative. This side is negative. So you know, this side is okay to. It's okay to reach your metal pliers in there and pull away at plastic on this side, but we can't really do the same on the positive side because you'll be shorting things out if you're not careful. I mean, you can stick your pliers in there, but you gotta make sure you're not touching up against the positive terminals of the cells. Now it's going to open up like a can of sardines, probably. Little bits of plastic going everywhere. Aha! I already see the capacity of the batteries, guys. So go ahead and take a moment to guess what the capacity of these cells are. I'll just say that. I'll just go and let you know it's not the advertised. Well, I should say that the combined capacity of these cells is not the advertised capacity of the pack that's on the sticker. I will say though that the capacity will be useful. It's similar to cells I have on hand already. So I wonder if anybody guessed what the capacity of these cells are? Again, in order to get 5200 milliamp hours, you have to have 2600 milliamp hour cells. The cells that this pack has are 2200 milliamp hours. Definitely not 2600. So this has been the case with practically every generic laptop battery I have harvested cells from. The cells simply aren't the rated. They're the cells that they put in these packs. They're not the rated amount. That's more or less. They're not the stickered amount. The best I ever got from generics was those purple cells, like what I showed you in this flashlight. They actually, from being completely dead, I can put in about 2400 milliamp hours into them things. You know, it's funny, these cells have a branding on them. They're not they're not LGs or Samsungs or anything like that, but they do have a brand. They actually have branding on them, which is rather interesting. Man, this thing is. Yeah, I tell you, these laptop battery packs are built like a tank. Even the cheap generic ones. The pack I had the least. The pack that was easiest for me to ever get into was a Toshiba laptop battery pack. Probably from, I think it was from a 2011 model machine, and it was a piece of cake getting into. And that's where I got my blue LG cam cells from that you may see in some of my videos. They were, matter of fact, the recent video I posted of doing the timekeeping cell swap in my Kodak ZI-8 wider case camera. You'll see those blue LG chem cells near the end of the video. Man, this thing is built like a tank. I tell you guys, it's tempting to manhandle this thing and pop it loose and get it over with, but there's risks that come with that, and you risk tearing up your cells, and when you tear up your cells, it could be catastrophic. If I can sneak these pliers in here, or these cutters in here, and try to weaken this plastic some, that would be mighty nice. Ah, yes. That was a good snap. Yes, it's more ideal when you can actually snap apart the entire freaking thing and just get right in. Okay guys, we are officially in. Finally, we got past that breaking point. Alright, so what we can do now, we can totally take this sucker out of that plastic. My gosh. So, there's the naked battery. Fully intact with the exception of one wire being snipped. And you look at this, guys. Well, yeah. Look at this. You see there it says, come on, camera, focus. Dadgummit. Yeah, 5,200 milliamp hours. Well, when you look at the actual circuit board, hey, at least the circuit board's being honest with you. Oh, I got it the wrong way. The circuit board is being totally honest here. It is a 4,400 milliamp hour pack. Now, this is certainly better than the 2,600 milliamp hours that the stock battery was doing. But still, it's not doing the rate of 5,200 milliamp hours. But for $20-something, what do you expect? And that's typically the story with these generic laptop battery packs. So now that we're finally in, well, first off, I'm going to get this plastic and crap off my table. I tell you, laptop battery harvest can be quite messy at times. Okay, now it's time for the burning question. Why the heck is this thing shutting off the computer when it says it still has like 15 to 20% remaining? Is it bad cells or is it a crappy circuit board? We're about to find out. Okay, so I'm gonna start up. I'm gonna test. Let's do the entire pack voltage. So nominal is 14.8. We're getting about 12.7 to 12.8 volts. Okay. So between, let's go ahead and see what these are doing. These cells are doing, on your far right, 3.58 volts. The second group is doing about 3.54. The third set, 3.59, and last but not least, the last two. Wait a second. Aha, we found our bad cells. Okay, so Okay, so this is what was causing our problem, guys. These two cells are only doing about, if I can get this on here, we're only getting about, come on, thing. Here, I'll do this. .04 volts. So these were bad. These are going bad. Now it could be one of two things. It could be this circuit board is not properly balancing the cells. Now these three sets were fine. They were roughly about 3.6 volts. However, these are only at 2 volts. So it could be faulty circuit board, not properly balancing out the cells, or one of these two cells could be bad. And of course, since they're connected in parallel, they're both being taken for a ride. Alright, so I'm now going to go ahead and start tearing down this pack. I'd say the construction of this thing is about, I'm going to say a B, as far as a letter grade. The pack overall was put together pretty well. You got the tape isolating all these, insulating the terminals and everything. But yeah, I'm going to say B. See up here they have this protective cover between the positive of this, but on these they don't have, and it's not necessary because these are actually facing, these contacts here are up on the side of the cell, which is at the same potential as, let's say, if the jacket was to break, it'd be at the same potential. I'm also not seeing the little plastic disc or the little insulating disc that they'll sometimes put on the top of the cells before they spot weld them. They're not present here. So I'm going to start snipping these wires loose. Now what's cool, one thing I should mention is if you're planning on rebuilding a battery pack using these, if you're going to be doing like a 2P, 2 parallel battery, I'd say try to keep the little keep the little tabs in place if possible, because that way you can solder up to the tabs if you're going to build your own battery pack. So they have a good bit of like packing tape in place to help hold the cells, hold the pack together, which is good. I'm going to go ahead and snip this wire here. And again, you want to try to isolate that circuit board as much as you can when you're working with these. Also, I'm going to go ahead and actually I'm going to take my cutters and cut this metal. Try to anyway. This stuff's pretty freaking strong. Okay, so I might end up... Okay, here it went. Okay, so these are the bad ones. Now, they're at 2 volts. Technically I could probably charge those back up, but given the fact that they're sitting at 2 volts or the rest are sitting at like 3.6, I'm not going to waste my time with them. Anytime I harvest a battery pack like this and You get some cells that are showing much lower voltage than the rest. It's safe to assume that those cells are bad. So in case you guys are wondering, I do plan on doing like a part 2 of this, where I toss the cells onto the Opus charger and see what they can do. Yeah, it's unfortunate that we had 2 bad cells in this pack. I mean, the pack was only about a year old. But the cells themselves, they could have been bad from the start. Really, to be honest. Again, I say to give this pack a B as far as construction goes. Good rigid exterior plastic holding it all together, and they have it taped up very well, but they're missing those little discs that I like to see on the positive posts of the batteries. It helps better insulate the positive or negative. Like, in other words, I wouldn't like to just rely on just the cell wrapper to do the insulating, because the cell wrapper is very fragile, and as you may have seen in the video where I was harvesting those purple cells, you may remember what happened there. And that could have easily also happened at any point in the battery's lifetime, because that spot was already there in the that little bitty hole was already there in the cell wrapping. Okay, so there's our little circuit board. Again, I do question if the circuit board was the cause of this failure. Like, for some reason it wasn't properly regulating the the first 2 cells, wasn't properly balancing them out. So I'm going to go ahead and I'm going to start pulling these tabs off. Now, the bad cells, these 2 here, I'm going to leave those to the side. I'm not going to bother with them. They're going to go straight to recycling. But these other 6, I think is a good score. I'm going to on this one, I'm going to do the positive first. Okay, so if this is your first time ever harvesting a laptop battery pack, use your needle nose pliers to carefully twist away. At the tabs, and be on the lookout for any spots in the cell wrapping. You just peel it back carefully. Okay, there's the final product. We have these 6 good cells, and we have the 2 bad ones. I got these grouped together in pairs of 2. These were how they came out of the pack. So these were together, those were together, and those were together. So I'm going to probably do a part 2 on this video where I put these things on a charger and use the charger's discharge test to see what the capacity of these things are. I'd imagine they're probably right up there at the rating, maybe even more. We'll see. These cells don't have that many cycles on them because, I mean, this battery started acting up not even a year after I started using it. So that's unfortunate, but at least I'll have 6 good cells out of it, and now I can go on Amazon and buy me another one. Buy me another battery. So anyways, hope you guys enjoyed this video. Thanks for watching. Well guys, that's it for this one. But it doesn't have to be. There's plenty more videos on the channel to check out. Also, if you liked the video, please click the like button. And if you absolutely hated it, there is the alternative button as well. But yeah, please subscribe to the channel. I definitely appreciate it. And remember to click the bell so that we get notified of all updates. Also, if you're interested in things aside from computers and technology, check out my second channel. It's CubeComp MTDX. Over there you'll find videos about weather, elevators, bicycling, and pretty much whatever else I figure out to upload. So yeah, anyways, hope you guys enjoyed this video, and thank you for your support.